So welcome everybody to Fix Information Exchange, our series of podcasts and videos covering various aspects of what the fixed trading community is up to and what the industry is using Fix for. Today we're talking about the European Consolidated Tape for Equities, and we're joined by Alicia Suminski, who's the Principal Product Manager from EuroCTP. So hello Alicia, and thank you for joining us.
Hello Jim.
So we're going to talk about what the Consolidated Tape is all about, how it's going to work, what the EuroCTP's role in all of this is, and in particular, because of course this is a Fix show, we're going to be talking about where Fix fits in and how Fix is being used across the implementation. And there's as much to help people actually get this live and implemented as much as anything else. So Alicia, perhaps if I turn it back over to you, I know you've got some material to go through, so let's have a look at that if you wouldn't mind.
Thank you, Jim. Hello, everyone. So today we're going to talk about what we've done here in Europe for the Consolidated Tape. We're covering equities and ETFs, and the whole idea behind the Consolidated Tape is to give you a view of the total available liquidity in Europe, and it takes the form of both pre-trade and post-trade. So we'll get into a bit more detail over that in the next few slides. I think the first thing we just wanted to highlight is that we're going live in July, so it's very close to now. We're currently still working with the authorization process with ESMA, and we've been working on this project for over 2 years now. Really excited to get to the point where it goes live. So in terms of the offering, we are covering, as I said, equities and ETFs, pre-trade and post-trade. And we're going to do a couple of things with the timestamps, which enable us to show you a perfect yet delayed view of what was actually happening in the market. And I'll give you a few examples and show you how we've used Fix to achieve this normalization of the timestamps. In terms of just a bit more detail, so pre-trade, you'll be receiving the European best bid and offer prices. For auctions that are embedded in the continuous order book, you will be receiving the European best auction price. And for frequent batch auctions, we're also delivering a separate message with the auction prices there. So for auctions, rather than a EBBO type presentation, you'll be getting the highest and the lowest of all the ongoing auctions, and you'll also be getting the volume weighted auction price and the total available volume in the combined auctions. Post-trade will cover all transactions executed on trading venues, but also all OTC transactions that are reported via an APA. In addition to that, we've got regulatory data, so both an instrument status and an order matching system status message, which we will be disseminating. The order matching system status will tell you if there's an ongoing outage with one of the trading venues, and the instrument status will tell you whether the instrument has been halted or suspended and what trading phase it is being made available to trade at the different execution venues. One of the things that's important to highlight is we're highly regulated, and the regulation does not allow us to attribute the EBBO or the auction prices. However, post-trade data is attributed, so you'll see where those transactions took place. In terms of our delivery, so this is why we're here today, and thank you for inviting us, Jim. We have a Fix SBE protocol, which we're going to deliver both in a multicast on-premise version and also via a web APA. We also have a website which is aimed at retail investors who can conduct data downloads there as well. In terms of how many trading venues are going to be covered, so it's just over 130 different trading venues. 10 APAs for the OTC reporting. So what, if we sort of lift the hood up and see what's going to happen. So we're going to receive the data from data contributors. We're going to normalize all the data received, including the timestamps, and I'll get to that in a moment. We consolidate the data, and then we disseminate it. So in total, the real-time delivery will be around 100 milliseconds, sort of as a maximum. If you're taking the data directly from our data centers, then that will be a lot faster delivery. Our primary data center is in Frankfurt, which is sort of the Barry center for the European market, considering that just over 50% of all messages will be coming from the UK because many of the MTFs have their data centers there. And then, of course, we have to cater for the northern part of Europe and Spain, Italy, etc., for the other data contributors. So in terms of accessing the data, you can, as I mentioned before, either absorb the data directly from us, from our data center, or via your an MSP. You can also get the data through your existing redistributors, data vendors. So there are many different options for each person wishing to consume the data, depending potentially on your use case. So, Jim, I just want to spend a few minutes before we get into really the thick of the fix protocol. I just wanted to explain a little bit what we're doing with timestamps, because one of the difficulties is this geographical latency, which there's nothing much we can do about. So what we've done here is that we've created a concept of what we call a normalization constant, which is an amount of time that we systematically add to the execution timestamp when we talk about post-trade, and the update date and time for pre-trade, but I'll get to that in a moment. So on this graph here, you can see that the execution timestamp is this green sphere. We receive the data in T0 in this particular case, that's the blue lozenge, and we're going to publish it once we hit the normalized timestamp, which is this red sphere. And you can see this double-sided arrow represents the normalization constant that we add to the execution timestamp. So as soon as we get data, we process it, we normalize all the fields, we add this normalization constant, and we wait for time to go by. And in this particular example, we've received a second message from another data contributor. And you can notice that the execution timestamp was actually earlier than on the message that we received first. And we add this fixed amount of time, the normalization constant, and we wait until we hit this normalized timestamp, which, as you can see, will happen before we hit the normalized timestamp of the first message we received. And this enables us, you can see on the right-hand side of this slide, to first publish the execution that happened first and to then publish the execution that happened next. So this allows us to put together this perfect picture that I was mentioning right at the beginning, but delayed by this normalization constant. The normalization constant will be publicly known. So in our instrument list, you will be able to find exactly how long this normalization constant will be. It is on an instrument per instrument basis, so that we really cater to the actual observed latency. Of course, a good example of this is, let's imagine we're only receiving data from one venue, then we can set that normalization constant to 0.
So basically, just to really kind of boil this down, this is to allow for the fact the venues are all in different places and the API is all in different places, and there's obviously the speed of light and all of that going on. So this is your basically your way of catering or sort of counteracting the effect of the speed of light and the venues all being at different distances away from your data center.
Yeah, that's exactly right. Because if we showed those two first trades in the other order, you might have the impression that the market is going up when in fact it's going down. So it's important to give that true picture, and also not favoring a particular venue that might be closer to our data center, which is in Frankfurt. So your natural follow-up question would be, well, what happens if we do receive something and the normalized timestamp is in the past? So this is the example I have here. The execution timestamp, as you can see, is even earlier than the other two that we've already received, but we received the data late. So our algorithm says, well, compare the reception timestamp, this blue lozenge, to the normalized timestamp, which is in the past. And in that case, we will publish it immediately. And what we will do there is we will seek to tell you, had we received it in the right order, i.e. earlier, I should say, would it have been published in the right order? So we're going to tell you, here's the transaction, and had we received it sooner, it would have been in a different sequence that we would have published the data. And so we add this out of sequence number flag, which you guys at Fix helped us identify within your library.
That makes sense. So just to understand what's happening here, this would be a case where the message, the line has temporarily gone slow, for example. Okay.
Exactly.
And just on which the way you compute the lengths of those normalization periods is something you're kind of measuring the actual latency of the messages as they come in, and are you adjusting these? Is that how you're doing it, or
yeah? So not intraday, because that would create some complexity to sort of tie it all back together. But from one day to another, if we start, so for example, when I mentioned that the example of when we would only have one trading venue contributing on a particular instrument. If today there's another one that starts to contribute, then obviously we would want to put a normalization constant that wasn't equal to 0. That's a very typical case of a situation where we would change the normalization constant from one day to another.
Right. Yeah, that makes sense. Good. Okay, excellent.
So sorry, I should just mention pre-trade. Pre-trade works in exactly the same way. We would add this normalization constant. It would allow us to calculate the EBBO at any one time, making sure that we've got the latest, most accurate information from each of the trading venues. So it works in exactly the same way. The starting point obviously isn't the execution timestamp because it's pre-trade. The starting point is what is known as the update date and time in the RTS. It's basically the moment at which the BBO was calculated for each of the trading venues that contribute data to that particular instrument.
Yes. And just to be clear on what that means for the pre-trade tape, I mean, obviously and indeed the post-trade tape, that obviously is where some of the delay, I mean, it's a tiny delay, but it's still a delay kind of comes from, right? Because you're allowing data to catch up, if you like, from the different venues. Yeah. Okay, that makes sense. Yeah.
Because our processing times are sub-milliseconds, very fast. We've invested in technology that allows us to really have very fast processing. But of course, if we didn't do the normalization, then you would get data in the wrong order and not necessarily show the accurate picture. So that was the reason for this choice.
Yeah, and that makes sense. I mean, I guess obviously from a pre-trade perspective, that would be quite impactful, wouldn't it? I mean, post-trade is obviously problematic, but you can kind of sort it out afterwards. But pre-trade, you'd end up with a book that just didn't look right.
Yeah, exactly. And then when you receive data that's very late, how do we work out if it's stale or not? If it would still make sense to recalculate an EBBO taking it, because it could be look like a better price, but it might be stale at that point.
Got it. That makes sense.
Yeah, so all of this is completely described in our service description, and of course we're available if anyone has questions. But if we move on now to the Fix SB and what we've done there, in our documentation, you'll also find our technical specifications for this Fix SBE protocol. We also make the data available via CSV as per the regulation. So here what I wanted to highlight is that we've taken your recommended practices and we've really followed them to the letter. We did add a few sort of bells and whistles. So I'm going to be highlighting those in the different next slides. The one that I wanted to draw your attention to on this particular slide is the fact that we've added the place of listing for the instruments that are multi-listed. So if ever you want to look at the data at a more granular level, using the place of listing as one of the aggregation keys, then you can do so with our feed.
Got it. So I guess the point you're making here is that you've gone from a fixed trading community document, and we'll provide links to that in the notes of this recording, and you've which of course is based very much on the regulation, and you've matched that in entirety, and you've also added on a few other things that you need to basically make the system perhaps more practical, if you like, on top of what the minimum regulation requirement is.
That's exactly right.
Yeah.
So
excellent.
So for post trade here, I've mentioned the place of listing, but in the regulation we have to add a suspicious data flag. So we've gone a little bit the extra mile there by saying, so the suspicious data flag is how it's named in the regulation, and when there is a suspicion that there's an erroneous price or size on a transaction, we need to flag it. So it doesn't get rejected, it just gets flagged. And we're going to tell you if it's a result of the size or the price, which led to this suspicious data flag being set to true in our messages. And we got the out of sequence flag, which I just explained, which is obviously on top of what was in your recommended practice document. And I just wanted to highlight as well the 5 key timestamps that you're going to find, which are, in addition to the normalization constant value, will enable you to understand exactly when we got the data, when we processed it, when we published it, when the data contributor published it, etc. So you've got the trading date and time. That's obviously our starting point for the normalization constant. We've got the time at which we received it. That's in the regulation. The time at which the APA received the data from their clients in the case of APA reporting. You've got the time at which we disseminate the data, and then, of course, the time at which the data contributor had published the data. So thanks to all of that, we're going to be able to calculate performance because the data contributors are bound by some pretty strict performance requirements in the RTS, but it will also enable us to adjust the normalization constant as mentioned before.
That makes sense. And as you say, I mean, if it's on here, then this is all data that the end users are getting as well, so they can see what's
Absolutely.
going on at a pretty low level of detail.
Exactly. That's exactly right. So pre-trade, as I mentioned, we've got continuous messages and we've got the auction. So the auctions are in 2 separate messages, but they have the same construct. I'm going to just quickly walk you through the pre-trade continuous specs. So as before, I've highlighted here in green the additional data points. So we still have the place of listing and the out of sequence flag, but we also have a couple of additional flags here, which are the uncrossing and locked market flags. So it's, while we expect the natural forces of the market to correct a situation where a bid is higher than an offer, because of the diversity of the European trading landscape, we did see, looking at historical data, that we would have cases where the bid would be higher than the offer. So when that happens, we will add the flag to tell you this market is crossed and it is the latest bid that crosses the offer, or it is the latest offer that crosses the bid. And immediately after telling you that, we will recalculate the EBBO, ignoring the latest bid that was responsible for the cross market or the latest offer. And we will add this additional price in the feed. So you can ignore it, but the advantage is if ever that situation were to persist, you that bid that's way above the market, let's say, is actually hiding what the actual value of the EBBO is, so you can actually see it, and then you can judge for yourself whether to take it into consideration or assume that actually even the bid that just came in is the one that crosses the market, but actually it's the offer that needs to catch up. So thanks to those different flags, you should have enough information to be able to make that call and see the actual value of the EBBO at any moment in time.
So you're basically saying, just so I understand this correctly, the EBBO you publish in the regular fields should never actually be crossed by what you're doing here. Is that right?
Well, it will be, when it is crossed, we'll show you another price, the price that is the same input, but without the latest one which crossed the market.
Oh, I see. So it's the other price that would show you what it would
Yeah,
be.
we're giving you a second price. Yeah. So we're not, because obviously the EBBO is still the EBBO. It's crossed, but that is the reality of what's being seen. So we're not altering the data. We're just giving you an additional data point that might be useful.
So as you say, I mean, if recipients of the data can then make their choice as to whether which of those fields they actually want to look at, whether they want to discard the temporarily cross market and go with the other data.
That's exactly right, and particularly useful in some of the smaller markets where there's maybe less market activity and those natural forces can't do their job as efficiently. That's really the genesis for this additional price point. And then of course we have the timestamps, nearly the same as for the others, but obviously we don't have the APA reception time, and we have an EBBO calculation time. So you know when it was that we calculated the EBBO. Every single input data that we receive generates an EBBO calculation. It might not be published because, for example, it's a new bid that came in below the market and doesn't impact the EBBO. So we're really going to be focusing on sending data that is meaningful. And then, of course, we have the reception timestamp, dissemination timestamp, and this famous update date and time, which is when the venue calculated their BBO. And it's that we use as the basis to calculate the normalized timestamp by adding the normalization constant. For periodic auctions, it's a little bit different. So for periodic auctions, there is no concept of a best bid or a best offer because they're auctions, and the data that we will be receiving is an indicative auction quantity and price. So in the RTS, it requires us to send the highest of all the ongoing auctions, the highest price, the lowest price, the total volume that is involved in all these auctions, and the volume-weighted auction price. So between those 4 data points, you can get a real picture of what's going on in those auctions, how much liquidity is available. And that picture will be, that message structure, I should say, will be the same whether it's a periodic auction embedded in a continuous order book, like an opening, closing, or intraday auction, or a frequent batch auction. But they won't be mixed together, so you'll get 2 separate messages. Obviously, frequent batch auction liquidity is of a very different nature to that of a opening or closing auction. So they're separate messages, and we get as well these same timestamps as we did for the continuous EBBO presentation.
And just to be clear, I guess across both continuous and the auctions, you are essentially having 3 different feeds, I guess, per instrument, right? So you've got continuous, and you could all be operating at the same time. Frequent batch auctions, continuous, obviously. I guess there will be times when you have the kind of, as you say, periodic or scheduled auctions going on at the same time as well on particular venues. So all 3 can coexist, and they can be, but they're separate.
Absolutely, they coexist, yeah. And you can decide to listen to them or not. Yeah. So now we're going to get to, well, I guess your question, Jim, could be, well, why did we choose Fix SB? So obviously Fix is an industry standard, and your recommendation is to use it in a SB type format. So for us, it's a very obvious choice. So in terms of performance, low latency encoding and decoding, low CPU overhead, these are all obvious, very good outcomes to using this Fix SB schema. Bandwidth efficiency, of course, it reduces the sizes of the messages. There's no overhead for the delimiters of the tags. And of course, as a developer, it's a much simpler process to develop to these types of feeds in this SB encoding. So that's really the choice. I've put up on this slide a couple of screenshots of the actual Fix SB schemas that we've made available to future users and developers.
So you've actually, yeah. So I was actually going to ask this. These are actually schemas you've made available to people, and I guess
Absolutely.
Just for the benefit of the audience who might not know what they're looking at. The simple binary coding operates on the idea of, as it says, schemas or templates, which basically dictate how the messages are constructed and deconstructed. SSPE is a fixed binary protocol that, like many of the native exchange protocols, it's been developed by us at the fixed trading community. It supports Fix, and it supports other standards as well. And I guess what we're looking at here is basically the instructions for how to take a kind of fixed model, if you like we looked at on the earlier slides, and basically bundle it up in a binary compressed format and uncode, sort of decode it, if you like, at the other end. That's what these are, isn't it?
Absolutely.
Yeah. And just perhaps just also to wind back a little bit, and I guess it's perhaps a little bit of where all the Fix stuff came from as well, because obviously there's a Fix presentation as well. Obviously, Alicia, you were very much involved in the working groups that came up with the design in the first place, and I think it's safe to say that we and our members put a lot of work into designing this, working with regulators very closely on the detailed design of obviously the regulation itself, but also our interpretation, our modelling, if you like, of it, and some of the things we've talked about, and particularly the flagging and the splitting up of the feeds is something that's very much come out of that process, which I think is a good result for the entire industry. One thing I do want to ask you about, actually, while we're here, is you mentioned MMT earlier, and trade flagging. This is obviously a post-trade thing. Would you mind just talking a little bit about how you've sort of accommodated that, and indeed what it is and what it means for users?
Yeah, you're right. We did spend a lot of time on deciding, should we also include the MMT efficient encoding 14 character string in our output. So there was a fair amount of back and forth. Obviously, the regulation requires a narrower set of sort of flag detail than what the MMT flags typically carry when they're being sent by the trading venues. So initially we thought, okay, if we receive one, we'll just publish it. If we don't receive one, we'll build one using the latest version of the MMT schema. And then it dawned on us that we might not have MMT flags that are in the same versioning. So then we decided, okay, we're going to deconstruct the MMT flags that we're going to receive anyway in order to go and populate all the different fields that are in the RTS. So as we've gone through this deconstruction, we might as well reconstruct it all in the same latest MMT standard version. So that's what we've done. And so hopefully that will be useful. The interest, of course, is that it carries more information than the deconstructed version in the fields that are in the RTS.
Got it. That makes sense. And for anybody who isn't intimately familiar with MMT and wants to know more, we'll put some information about how to learn more about that in our notes as well. And perhaps just to give you a quick 30 seconds on it, it was a data standard for describing the different types of trade flags in terms of where a trade came from, in terms of what type of market mechanism it came from, and various flags, particularly regulatory flags, like, was it an algo trade? Was it a benchmark trade? All these kind of other things you find in the regulation, they're all in there as well. And it gives a very, very compact and normalized way of describing all of that. So again, details to follow in the program notes. And that's very helpful indeed. So we've got to, I guess, at the time of recording, we are literally about 2 and a bit months away from go live on this. So it sounds like all the hard yards have been done. This has been I think, 15-year process at least. I'm sure we've been talking about this in fixed circles back in 2010, 2011. So it's been a long road, but we're nearly there. So you're ready to go. I guess the market's getting ready to go. You're onboarding people, and
Yes, we are.
hopefully come July, we'll have a great solution for the market.
Yeah, I think we will. I mean, we're seeing a lot of take up, a lot of people already going through the process of onboarding as a user. The data contributors, all onboarding is going very well, and testing. So, yeah, we're very confident that we'll be ready in July.
Fantastic. And perhaps just to close, I guess a little note on the UK consolidated tape, which is obviously not what we're talking about here, and that's a whole different implementation clearly. But as Fix, we have an Equities Consolidated Tape working group, which is continuing its good work, and we have more work to do on the UK side of things as the FCA comes up with its requirements over the forthcoming months. So if that's something that is of interest to viewers, then please do get in touch with us, and we'd love to have your input to that process. In the meantime, I think that's everything from us. Alicia, unless there's anything else you want to add as any closing remarks?
Oh, well, thank you very much for inviting us. We really appreciate our collaboration with the fixed trading community, and it's been extremely helpful to have you at our side for this whole process.
That's great. Thank you very much indeed. Alicia, thank you so much for your time and putting together the materials. We hope you found that very useful, everybody. Please provide us with any comments or feedback as you see fit, and hopefully we'll see you next time. Thank you very much indeed, and goodbye.